Okay, so today we're going to talk about recursion. Okay, we're going to talk about recursion, and recursion it's another approach on how to write algorithms that have a recursive behavior. What is recursive behavior? So basically we can say that recursion or recursive function, it's a function that calls itself. It's a function that calls itself. And we are going to start from the very basic example of calculating the factorial. So you know that the factorial of a number, okay, for example, n factorial is equal to what?
n minus 1 plus n minus 1.
Yes, so it's equal to n multiplied, or let's say 1 multiplied by 2, multiplied by 3, multiplied by several numbers, okay, n minus 1 multiplied by n. Okay, so if we take the example here of 1 factorial is equal to, or let's start by 0. 0 factorial is equal to 1. Okay, and if we have 1 factorial is equal to 1 as well. If we have also 2 factorial, okay, is equal to 1 multiplied by 2. Okay, it's equal to 2. If we would like to calculate 3 factorial, so it's equal to 1 multiplied by 2 multiplied by 3. But 1 multiplied by 2, what is? What is it? It's 2 factorial multiplied by 3. Now if we do the same for 4 factorial, okay, we can say that it is 1 multiplied by 3 by 4 equal 3 factorial multiplied by 4. So this kind of function is recursive. We can say that if n factorial is equal to fn, so how can we write fn? Fn is equal to what? F n minus 1 multiplied by n. So we can say that the function n is based on its previous values. Okay, and I think you already made several recursive function mathematics. Okay, you're going to see several ones here. So the traditional way, without using recursive behavior, how can we solve this one? We can use iterative method. This is the thing that you have already done in CS102. You have used iterations. Okay, so we can make a function factorial. It takes a number. Okay, we start the value by 1 because this is like the base case or first value. If the number is 0, so this is a special case, we're going to return 1 because 0 factorial is equal to 1. It doesn't apply to the same strategy. And for all the other numbers, we're going to start from 2. Okay, and while I is smaller than number or equal, we're going to make the product, the previous value multiplied by I. So this is an iterative method. Okay, and we can see here. Okay, so this is the function factorial. This is the function factorial. Now I can calculate the factorial of these numbers until 15. So you can see the factorial of 0 is 1, the factorial of 1 is 1, and so on. Okay, every value, so 120 is equal to 24 multiplied by 5. 720 is equal to 120 multiplied by 6, and so on. Okay, so this is a very simple function. We start by product equal to 1, and every time we're going to update the product until we reach the value of n. And this method is called iterative. This is the method that you do now. Okay, how to solve this using iterations. But in programming, there are other ways or another approach to solve this, not using iteration but using recursion. So what is a recursion? It is a function that calls itself. So the function is going to make a self-call. But we have to be careful here so that we cannot go into an infinite loop. So let's try to think about how we can something recursive function. So I'm going to write here public static long. I'm going to call it R for recursive and long number here. So the idea here is that what we do, we're going to make R factor of something number minus 1. Okay, so the function is going to call itself recursively. So this function here should call itself. So what is the factorial of a number based on this one? Imagine that this is factorial of n. It's equal to the factorial of n minus 1 multiplied by n. So basically I can write n multiplied by r factorial of number minus 1. Okay? So, and here I have to return something, so I can just return this value. Okay, it's number. So what happens here? Yeah. Now, yeah, let's try. If I'm going now to calculate for, let me calculate for 2 only. Okay, let me calculate for 2. I'm going to change here r factorial. Calculate only for 2. So I'm having a stack overflow. Stack overflow, it means I have generated several numbers and the memory cannot accept more numbers. Why this is happening here? So what is going to happen here? This is kind of infinite loop. Is it going to stop here? So number, so if I make 10, I'm going, or if I make 2, it's going to make 2 multiplied by factorial of 1. And factorial of 1 is going to be called again. So it's going to be 1 multiplied by factorial of 0. Okay? And then 0 factorial minus 1. So it's going to go infinitely. It's not going to stop. So here I have to find the condition where to stop the loop. Okay? If I reach a certain value, I have to stop. And this condition is called the base case. So for every recursive function, I need to define base case. It's the condition where to stop the value. So here, if you look at these ones here, what is the condition to stop? What is the condition to stop? When the number for 0, it's already 1. So let's say we can stop even here. Sahullah. So what to stop here? What is now the if statement? If what? Number. We can stop at 1. Okay. If number equal to 1, what to do? We're going to return 1. So if the number equal to 1, what is the factorial? It's 1. So now if I return 1, all the other values are going to be evaluated in the other way around. Okay, so let's look now. For 0, we did not define a case for 0. So maybe we have to, okay. You have to define also the case for 0. Otherwise, it's not going to stop. Okay. If it is 0, we return 1. Are we doing fine? Okay, so I can put 3, I can put 4, I can put 5. Okay, because now I made a stopping condition that is called the base case. Okay, so you can see now we can solve this function using two different approaches. The first approach is iterative. We use a for loop with an index I, and every time we make the update. The second approach is called recursive. It's a recursion. Okay, so recursion, it means the method is going to call itself recursively. Okay, until it reach a base case, and from this base case is going to evaluate. So what is going to happen here if we're going to make a trace for this one? Look now. Let's print the number to see what is happening. Let's try to evaluate only 5. And you print the number. So we want to calculate factorial of 5. صح ولا لا? Okay, and factorial of 5 is going to call factorial of 4. And factorial of 4 is going to call factorial of 3. And factorial of 3 is going to call factorial of 2. Until factorial of 2 calls factorial of 1. When we call factorial of 1, we know the value. Okay? So now, this is the number. I'm going to write search for factorial of last number. Okay, last equal I'm going to use printf, it's better here. Okay. So I'm going to look for factorial of number. Okay. And this value is what? Is factorial of number minus 1 multiplied by number. Okay. So this is number %d. So this is here %d, and this is here %d. Okay. Factorial of %d, number minus 1, is not known. So is not known. So here we have the first %d is number, then I have number minus 1, and then I have number, and then I have number minus 1. Okay, so now we're going to have an execution that illustrates what is happening. Let me add the /n. Okay, we want to calculate factorial 5, which is equal factorial to 4 multiplied by 5. But factorial 4 is not known. Do we know the value of factorial 4? No. So we're going to go for factorial 4 to calculate. It's equal to factorial 3 multiplied by 4. Factorial 3 is not known. And then we go for factorial 3 is equal to factorial 2 multiplied by 3. Factorial 2 is not known. Okay, and here we can write just to have another S out, it illustrates better. Okay, S out, factorial of 1 equal to 1 is known. Okay, rolling back. So this is what is happening now. Okay, so factorial of 1 is known, rolling back. So now from factorial of 1, when I know factorial of 1, I will calculate factorial of 2. Then when we know factorial of 2, we're going to calculate factorial of 3. So we're going to go the way back. Okay, بدأنا من 5 إلى 0 إلى 1. When we reach 1, we're going to go in the opposite direction to calculate the values. Okay, so this is the concept of recursion. So these values are going to هذيك علاش الايرور اللي كانت من قبل stack overflow. So the values are going to be stored into a stack. What is a stack? Last in, first out. Does it apply here? What is the last value? 1. So when I know 1, the last value is going to be served. Okay, find the value of 1. Then I'm going to find the value of 2. And here before the last. Then the value of 3. We're going, when we go back, it's like a stack. Okay, we put them one on top of the other, and then we're going to unstack the values one by one. This is one of the uses of the stack structure. Okay, is in recursion. الآن في operating system there is a stack. Okay, that is actually managed by the operating system. Okay, where to store the temporary values. So the factorial of 5 is going to wait for factorial of 4. Factorial of 4 is going to wait for the value factorial of 3. Factorial of 3 is going to wait for the value factorial of 2. And factorial of 2 is going to wait for the value factorial of 1. When we know the value of factorial of 1, we're going to determine the factorial of 2, then the factorial of 3, then the factorial of 4, and then the factorial of 5. Okay? So this is the strategy. So let me show you, I hope that we have some slides here. Look at this example. Here, this is an illustration of the concept. So we start to find the value factorial of 5, which is equal 5 multiplied factorial of 4. And then this is equal to 4 multiplied by factorial of 3, which is equal to 3 multiplied by factorial of 2. And this is equal to 2 multiplied by factorial of 1 until we find 1. Now when we find 1, this is a stack. Last in, first out. Last value is 1. So it's going to be the first one. So I'm going to replace the value of 1 factorial in the memory. Okay. And then 2 multiplied by 1 is 2. So I know the value. And then I will return 2. When I return 2, we're going to evaluate 3 multiplied by factorial of 2. Okay. Which is going to be evaluated to 6. And then return. When it is returned, it's going to return the value 4 multiplied by factorial of 3. When it is returned, we're going to evaluate the value 5 multiplied by factorial of 4 until finally we find the value that we are looking for. So this is the concept of recursivity, recursion, a function that calls itself. And the intermediate value are going to be put into a stack, okay, until we arrive to the base case. And the base case, this is the, let's say the initial, okay, the initial value for the recursive function. Is it clear? Okay. And finally we can find the value for, now if I want to do the factorial of 6, it's going to be the same thing. Okay. We're going to start from 6, waiting for 5, and so on. And we repeat the whole process. So this is the simplest case about the factorial. Now we're going to see other kind of functions. Okay, so the second most popular function for introducing recursivity is called the Fibonacci series. Have you heard about Fibonacci series? No. Okay? So this is the structure of the Fibonacci series. It's defined by the function xn is equal to fn is equal to fn minus 1 plus fn minus 2. Okay, we can write xn is equal to xn minus 1 plus x of n minus 2. So now here we have to start from two values, and under n minus 1, n minus 2. f0, by definition, it's 0, and f1 is equal to 1. So this is our base case. Okay, this is our base case from where we start. Now, if we want to define f2, what is f2? Is equal to f1 plus f0. f1 plus f0, 1 plus 0, which are defined in the base case, is equal to 1. Now for f3 is equal to f2 plus f1, which is equal to 1 plus 1 equal to 2. Okay, if I want to define f4 equal to f3 plus f2, f3 equal to f2 equal to 1, so the sum is equal to 3, and so on. f5, 3 plus 2 equal to 5, and so on. So it's going to, every value is equal to the sum of the two previous values. As simple as this. This is called the Fibonacci series. It's already known. You can even look at the internet. It has several properties and it's also useful. So now we're going to develop a method for which you give the n, the value of n is going to return you the value of fn of the Fibonacci series. And likewise, similarly to the factorial, we can do it either using iterative process or we can do it using recursive process. Okay. So let's look at how we can make it iterative. I'm going just to show the iterative version. Okay, so this version is iterative here. So this is called the iterative version. It's not recursive, this one. So of course here we're going to give the input as the number n, and we're going to return the value of the Fibonacci series. Okay? If equal to 0, we return 0. If equal to 1, we return 1. This is the base case. Even for the recursion, even for the iterative process or version, we have also the base case that are the values assigned to the initial, okay, to the initial values. Then we're going to make a for loop that goes from 2 until the number n. And every time we're going to do fn equal to fn1 plus fn2. It means fn minus 1 and fn minus 2. Okay, so in the beginning, fn is equal to 0. We don't know the value. Fn minus 2, this is f0 in the beginning. It's like we write fn minus 2. And this is fn minus 1 equal to 1. This is the value of f1. And then we're going to calculate the value fn as the sum of both. And in each iteration, we're going to update fn2 is equal to fn1, and fn1 is equal to fn, and then we repeat. واضح? So we can do here s out, okay, print f, So this is, we're going to look for f percent I is equal to f percent D here. Plus f percent D. So the first percent D is the I, and then I minus 1, and then I minus 2. And then I minus 2 here. So we can see here, and then after switching, so after switching, so we have here fn minus 2 is equal to percent D. I'm going to put percent D here, and equal to percent D. So this is I minus 1, and this is the value itself, fn1, and this is I minus 2 and fn2. So we can see now, I'm going to remove the recursive version, and let's take a value, one value of 5 only. I need to put slash n, by the way, slash n here and slash n here. Okay, so what we are looking for now, this is iterative. Iterative is not, we don't start from the top to the bottom. No, we start from the lowest. Okay, from the bottom to the top. So we start from f2 is equal f1 plus f0. Okay, so after switching, so and here let's calculate the value. What is the value? Equal another percent D. So f2 is going to be equal to what? fn1 plus fn2. We're going to make the sum. Okay. So the value is 1, is 0 plus 1. Then after switching, f1 equal to 1 and f0 maybe I have something. No, after switching, yes. So I have to put this after I make the switch here to make it correct. So f1, fn minus 1 becomes 1, and this one becomes 1. So now I'm going to have 1 plus 1, so it's equal to 2. Okay? And then after switching, I'm going to have 2 and 1, and then I find 3. Okay, until I reach the value of Fibonacci of 5 equal to 5. So these are the steps using what? Using iteration. So using recursion now, how can we do it using recursion?
We start by the base.
Yeah. Let's do it. So public static is going to return a value long. Okay, recursive Fibonacci int n. So what is the base case here?
N equals 0.
Yes, so we need to define the base case. If n equal 0, return 0. If n equal 1, return 1. And then return what?
R. The method itself.
Yes, rfib.
N minus 1.
Yes.
plus RFIP and minus.
Yes, it's as simple as this. Okay. Now if I change RFIB here, okay, you can find 5 as well. So you can see now with recursion, sometimes you need to write much less code than if you write with iteration. Okay, so this is now the recursive version. Okay, so the steps are quite simple and straightforward. First of all, what is your base case? Second, call the method itself. Okay, it's like this. So this is all about recursion. We've made almost the 2 most important introductory exercises. And then, starting from tomorrow, we're going to do other type of recursive functions, okay, especially Taylor series and other types of functions as well. But the principle is always the same. It's always the same. Okay? Any question? That's fine for today.